welcome to Living Answer Key for Stoichiometry problems number 5. We're going to be dealing with solid solutions and gases in this, so you want a periodic table and you would like a calculator. As always, whenever you're going through this, I suggest you pause the program, try each one yourself, and then watch and make sure you did it correct and see where your mistakes are. Also, make sure you balance every equation before you get started, so I'd take a look at question number 1, see if it's balanced, and go from there. Alright, so it's not balanced. And you notice that I start with 3 oxygens and I end with 2 oxygens, so I want to put a 2 here and a 2 here. That gets me 2 carbons and 4 oxygens on both sides, respectively. So let's read the question. Below is the equation for the synthesis of carbon dioxide. How many liters of carbon monoxide gas, which is here, will be needed to react completely with 7 liters of oxygen gas? So, which do I know the most about? I know the most about oxygen, so I can get moles of oxygen. Now, for this worksheet, you're going to be able to use any of these equations, either moles equal mass over formula weight if you're having a pure solid, pure liquid, or pure gas, moles equal molarity times volume in liters if you have a solution, and then the new one, moles of a gas equal volume in liters over 22.4. This is the one we're going to start with here in question number 1 because we have liters of a gas. So we do 7 liters of gas over 22.4. When you put that into your calculator, you get 0.31 moles of O2. Now, what you have to do is you have to take a look at the coefficient ratio. We're going from O2 to carbon monoxide, so that's going to be a 1 to 2, so I'm getting larger, so I'm going to double this number, which if you punch it in your calculator, is going to look like 0.62 moles of carbon monoxide. The question, though, said, okay, how many liters of carbon monoxide, and it is a gas, so I'm going to use that equation again and set that equal to x over 22.4. And then when you get your number, 13.89, and that's going to be liters of carbon monoxide. All right, take a look at the next question. Make sure you can balance it and give it a start. This one was probably a little bit tough to balance. You need a 1, 6, 6, 6 to be balanced. And the question says, how many liters of oxygen gas at standard conditions are required to react with 30 grams, oops, that should be grams, of glucose? Okay. So again, if you get it, go ahead and pause the program. So obviously we know the most about glucose, so we can get moles of glucose. And when you're looking here at your different equations, the only one that we can use here, we have mass, so we're going to divide it by its own formula weight. Formula weight being 180 for 6 oxygens, 12 hydrogens, and 6 carbons. When you do that, you're going to get 0.17 moles of the glucose. Now, we got to check our coefficient ratio. Going from here to here. That is actually a 1 to 6 ratio, so I'm going to multiply this by 6. When I do that, I get 1.02 moles of the O2, but I'm looking for liters, and it says that this is a gas. Okay, so we're going to go ahead and say this is equal to x over 22.4, multiply both sides by 22.4, and you're looking at 22.85 liters of O2. Alright, take a look at number 3, try to answer the question, and then come back when you're done. Alright, so you're looking here, and first of all, it's balanced, so that's working well for us. And then we can see that we have some interesting information. Okay, I know that I have, I'm not written it up here, I know that I have 0.321 molar HCl, that's a molarity, and we're going to neutralize 0.005 liters of a 1.28 molar KOH solution. So when you're looking here at your optional formulas, there's only one that we can use because both of our things are solutions. We're going to have to use this one twice. So let's go back here. So I'm going to get moles of KOH, that's the one I know the most. I'm going to take its molarity and multiply it by its volume in liters. When you do that, you get 0.0064 moles of KOH. Because it is balanced and written, it is a 1-to-1 ratio, so that's also how many moles of HCl I have. But the question wanted to know how many milliliters of that I would need. So we're going to go ahead and we're going to say, hey, I know the molarity of the HCl, I want the volume. When it comes out of my calculator, that's what my calculator reads. I'm going to move the decimal. So now I know how many milliliters of hydrochloric acid. Alright, number 4 is nice and challenging. Make sure you take a look at that one. I would make sure you balance it, and then gives you a little thinking here for the second part. Alright, so balancing looks like a 2, 1, 1, 2. And then when we're going to go ahead and we are going to write this. Oh, I don't have any of this typed in. Alright, we're going to pause. Alright, so we looked at this problem. It says calculate the mass of iron. So this is our iron here, and I want to know the mass of it. It can be formed from 135.5 grams of iron to oxide. So 135.5 grams of iron, oh, I'm sorry, 3 oxide. So again, what do I know the most about? I know the most about my iron oxide. I know I have 135 grams divided by the formula weight of 2 irons and 3 oxygens. When you divide that, you get 0.85 moles of Fe2O3. Now, we're going to go from here to here. That is a 1 to 2 ratio, so I'm going to double my moles. So I'm looking at 1.7 moles of iron. Now, this is where people probably run into issues because it's a liquid. People want to say, hey, well, then I don't have a molarity, so therefore I can't answer this question. If you say pure solid, pure mass, pure solid, pure gas, or pure liquid, and it wants mass of it, all you got to do is set it equal to x over your formula weight. Iron is 56, multiply both sides, and you get 95.2 grams of iron. Alright, I'd say check the next equation, see if it's balanced, and then try the problem. Alright, the question is balanced, and we're going to start by finding moles of our sulfuric acid. You're going to take the molarity of this sulfuric acid, which is 2.75, and you're going to multiply it up against the volume, which when you move it, 1, 2, 3, and it's 0.525 liters. You get 1.44 moles of H2SO4 because it's balanced. It is a 1-to-1 ratio, and it wants to know volume of hydrogen gas, so we're going 1 to 1. So I have 1.44 moles of hydrogen gas. It wants to know volume because it's a gas. I'm going to set that equal to x over the 22.4. You're looking at 32.26 liters of hydrogen gas. On the back, pause the program, see if you can't do number 6. Alright, so first of all, to balance, you're going to need a 2 and a 2. This is a double replacement reaction. That will not be on a quiz that you have in this unit, but it never hurts to review. And the information that we have is that we know that we have 5 grams of calcium hydroxide, and we want to know how much of an HCl solution would be required to react with that. So I can find the moles of CaOH. So I'm going to go 5 grams divided by 74, that's 1 Ca, 1 O, 1 H. When you do that, you get 0.068 moles. It is a 1 to 2 ratio, so you're going to double it. So we're looking at 0.14 moles of HCl. Now, this is a solution. We know that a solution, we know that is equal to molarity times volume in liters. Luckily, we have the molarity. We're going to plug that in right here. And I want to know the volume in liters, so we're going to divide both sides by 0.01. So we're looking at 1.4 liters or 1,400 milliliters. Take a look at question number 2, see if it's balanced, and try to get an answer. Alright, it is not balanced, so you're going to go ahead and you're going to put a 2 here and a 2 here. And the question here says, what volume of chlorine gas would react with 24.7 grams of sodium metal? So we know the most about sodium, so we're going to say 24.7. We want to put it into moles divided by its formula weight. You get 0.017 moles of sodium. We're going from sodium to chlorine, so we're looking at a 2 to 1. We're going to divide this number by 2, which is going to give us 0.54 moles of our chlorine gas. We want to know the volume of chlorine gas. We're going to set that equal to x over 22.4. You're going to be looking at your final answer of 12.10 liters of chlorine gas. The next question says, what mass of salt can be produced from the exact same amount? So I'm just going to pull down my moles here because I have the exact same amount. I could divide it by 23 again if I wanted. Or I know I have 0.017 moles of Na. This is a 1 to 1 ratio. So that's how many moles of salt I have. And it wants to know the mass. I'm going to multiply it by its formula weight. You're looking at 62.06 grams of sodium chloride. Now, if you take all this product and you dissolve it, so if I take all this and I put it into water, now your molarity is moles per volume in liters. So that's my mass, but I'm going to actually use this number and bring it down here. I'm going to divide that by the amount of water. Now, we have 750 milliliters here, so I got to move it. It's going to be 0.75 liters. And then, so your molarity is 1.43 molar NaCl. All right, check out, see if number 8 is balanced. Knock these 3 out, and then come back and see if you did it correctly. All right, it is balanced. And the first thing we can see is it says we have 560 milliliters of hydrogen gas, which is interesting because it's in milliliters and it's a gas. At STP, it's going to react with copper 2 oxide. How many grams of copper 2 oxide are we going to need in order to completely react with the amount of gas that we have? So I have enough information about the gas to get it into moles, but be very careful. I cannot use 560. I have to use 0.56 because it needs to be into liters. Divided by 22.4, you got 0.025 moles of H2. All of these are going to be 1-to-1 ratio, so that's how many moles of CuO I have. And then once the mass of that, so I'm going to multiply it by 80. How many grams of copper are going to be produced? Now I'm going to go from here to here. We're using the exact same amount of gas, so I can bring those moles down, or you can divide it again if you feel so moved. It's a 1-to-1 ratio. That's how many moles of copper I make. And then I'm going to multiply by its formula weight to figure out how many grams of copper I make. Last but not least, I'm going to take the same amount again, and I want to know what mass of water we're going to have. So I'm going to say this is, again, a 1-to-1 ratio. That's how many moles of water I have. Multiply by its formula weight, and you get a mass. So hopefully you're feeling 12 for any questions you have in this class.